Hi guys, welcome back to my YouTube channel. So in this lecture, we will be concluding our behavior and observation on the PN junction diode. So I hope these lectures will be quite enough for the EDC, electronic devices and circuit things. So in the electrical circuit or analog devices, we will be covering the modeling of diode and everything detailedly there. So in this class, we will be winding up with all the basic representation that is aligned with your college syllabus or even gate syllabuses. So let's think the first take the first thing, that is film factor. The film factor is a thing that will be depending on this is the formula Vm Im, which is nothing but Pmax, divided by VOC ISC. So this will be the factor. Practically this value will vary from 0.6 to 0.7, which is similar to the diode cutoff voltage. The second one, which is conservation efficiency, eta, which is equal to P out divided by Pin. So the P out by Pn, which is the output electrical power and input optical power that is given into picture. So this can also be written in the Pm divided by Pn. So we didn't know Pn formula, but Pm formula we can take it. Pm by Vm divided by Vn. Okay. So this is what the efficiency or optimization. This can this conversion efficiency can written in terms of film factor. So this one can be replaced with this kind of thing. So if we multiply this one, then this can be written in the term of film factor into VOC ISC divided by Pn, right? So this is one thing. So third thing, which is nothing but quantum efficiency, which is bar over there. So the thing is that number of electrons generated. So number of electrons generated to that of number of photon incident. So number of photon incident. So this is the quantum efficiency thing used to find out incident. Okay, so this is theoretical idea. So this can be written in the time of number of number of energy generated, which can be written as IL divided by Q divided by number of photon incident can be termed in P in divided by H nu. Okay. So if we rearrange it, then IL into H nu divided by P in into Q. So this is the formula for quantum efficiency. Okay. The last thing, that is responsivity. So which will be named as R. So R, which is named as IL divided by Pn. So which is the generated photocurrent to that of incident photo power. So the responsivity can also be written in terms of quantum efficiency, that in the last from the last thing, if we substitute the P in here, then we will be able to get Q the bar eta bar to that of H nu. Okay, the IL will be get cancelled here. So this is the thing, the responsivity. So these are the four different criterias that need to be known. So these are the four things that will inform us how the solar cell, or how efficient the solar cell can generate a current. So based upon this observation, we can choose the solar cell based on our application. If we need a responsibility, if it is an dull light area, we need for smaller incident of light, it need to produce more current thing. Then we have to choose the thing accordingly. So this will be quite application based upon the necessity or area of the thing where we are going to place our solar cell. We need to choose the thing. So from this, our solar cell can be taken. The solar cell observation is fine. So next, let's take us another one special device, that is LED. So in direct and indirect band gap semiconductor itself, I have clearly given you some example on the LED thing. So how this LED can be represented is that the simple normal diode, but they will usually mention the symbol this way. So as a light emitting diode. So the light emitting diode is a full form of that. So the light emitting diode can be getted only from directed band gap semiconductor where their momentum is conserved. So this I detailedly discussed in, I think, lecture 15, I think. So please go on watch there. Don't worry, I will be explaining here also. In forward biased PN junction diode, holes are injected from P to N side and electrons are injected from N to P side, that we know already. Therefore, there is a recombination of injected holes in N region and recombination of injected electron in P region. Since diode is made up of direct band gap material, the recombination process will give light. So this is how the recombination process will give light. As there is a momentum, conservation of momentum, thus recombination will be emitted as phonons. the recombination will be emitted as phonons. Okay, as light. Okay, I hope it is understood for you guys. So let me give you the best example is the GaAs, gallium arsenide, which is another very important example. So there is another one case study that we have to do. So in GaAs, so this is the direct band gap semiconductor device. Silicon act as a dopant in GaAs crystal. So in this crystal, if we replace it with silicon, so silicon has 4 free electrons at outside, where Ga has 3 and arsenic has 5 outermost shell. So if silicon is if Ga is replaced with silicon, then it will act as a n-type material, right? Or else, if the silicon is replaced by arsenic, then it will act as a p-type material. Okay, so this is the thing where based upon the doping atom it can act as p-type or n-type or anything. So this is one important thing. Even in gate 2015, I think there is two more question asked on this. I think it's a MSQ question or a multi-choice question, I'm not sure, but I am pretty sure that question is already asked in. So when silicon atom is replaces the gallium side, in the gallium side it is replaced, it will become n-type. If silicon atom is replaced the arsenic side, it will act as a p-type. So this is one of the very important thing that you guys have to remember. So from this pretty much I have covered all the things as on LED and anything. So in LED you guys know the radiative decombination will occur since external electric field is responsible for injection of the charge carrier across the junction. The recombination charge carrier is giving law of light. So this is electroluminescence process. So this is one kind of process that will act on the LED will spontaneously emit more things. The advantage is that it is lightweight, small size, and even it is used for low power consumption and long life can be expected in these kind of devices. The disadvantages is that not highly directional, so it will be that will not be that much focused like a laser something, and not chromatic, so not a single wavelength, there will be multi wavelength will be passing over it. So these are some kind of advantages and disadvantages that is there. So I hope from this we can wind up our p-n junction diode observation and case study analysis. So from tomorrow we will be going through mass cap. So after the mass cap, no sorry, not a mass cap, I will be going over BJT. So in BJT, we will be going over all different types of observation and all the different types of modes. I will be going over the theory and the background devices only. In electrical circuits, electrical circuits or analog devices, what are the subject you guys may name it. In there only, we will be seeing the diode modeling and the BJT, the transistor modeling, like RPI model or even the HI model, any kind of models that both models will be going seeing there. So from here, I'm closing the discussion on the p-n junction diode. So I hope I have given a best example and give explanation on all of the things. Even if you guys have any doubt, please ping in the comment section. I will be there to clear all your doubts. So stay tuned guys for next lectures. Thank you. Please like, share and subscribe the channel.